We're continuing with Unreal Developer Day. This is day 2, and we're super excited to be here. And we have an exciting talk planned on something very new, and Sid and I are excited to talk about it. So, our topic for today is transitioning to verse in UEFN. So, hi everybody, my name is Karan Parikh. I'm CEO and co-founder at Green Range Studios. We're an Unreal Authorized training center based out of Mumbai, India. I've been using Unreal for the last 10 years, and we also do a lot of projects on Unreal. Joining me is Siddhante.
Hello everyone, I'm Siddhante, but you can call me Sid. And just a quick note over here, so my name's got an E at the end, but that E is silent, so it's not Siddhante, it's Siddhante. So I'm an Unreal Authorized instructor, and I'm a game programmer and trainer here at Green Rain. I work mainly with programming, working on C++, Blueprint, and more recently on Verse Code as well.
Right. Yeah, so, we've been using Unreal extensively at the studio for a number of projects across many different industries. And UEFN is new. It's obviously in beta right now. We'll be talking more about what UEFN is. But before we get into any of this, I just want to get a better read of everybody in the room, understand your backgrounds a little bit so I can speak to that better. So you can just raise your hands up if the answer to the question is yes. How many of you already use Unreal Engine? Okay, great. Most of you do, that's great. How many of you are using C++ with Unreal right now? Okay, a few of you. And how many of you are using Blueprints? Great. And then how many of you use other engines and other languages like C#? Okay, great. Any Python folks in the room? Nice. Anyone who's used a functional programming language before, anything like Haskell? Okay, great. 2 of you. Okay, awesome. Nice to see that as well. Good representation here. And how many of you have no prior experience with programming or code whatsoever? Okay, few people. You're still in the right room, don't worry. This talk is still for you, and there's definitely some stuff at the start of the talk that will be very relevant to all of you as well. So, seems like most of you already know what Unreal Engine is and are using it, but how many of you don't use UEFN or haven't used it yet? Okay, still a few people here. I just want to cover a few highlights of what it is very quickly. And so it's a new offering from Epic that basically allows creators to put their content right into Fortnite, right? Fortnite is a game that's played by millions of people over the world. The number of active players in that game exceeds the population of the United States. So that's an extremely, extremely large target market for anyone looking to build a game today. So UEFN brings an Unreal Editor-like interface and allows you to publish your content, your gameplay directly into Fortnite. And you can have a custom island, so to speak. So it's your own little game that's running within the Fortnite ecosystem. And it's published on all the devices that Fortnite can run on. So it's by far the fastest dev and publish pipeline that I've come across, especially when you compare it to something like Unreal, where it takes extensively long. If you're trying to create a title for a console or something like that, that dev cycle takes extremely long. Through this, directly from UEFN, you can push your content right into Fortnite. So at its core, it has a subset of the features available in the main Unreal Engine, right? So UEFN is a separate application from UE5. You can get it from the Epic Games Store today, and it's in beta, but despite it being in beta, you can still push your content to all platforms, like I mentioned before. In addition to having a bunch of features that are already in the Unreal Engine, with this, there are a number of Fortnite assets that you can use. So we're talking about actual geometry, meshes, things from Fortnite, maps. You can leverage and build on top of all of this, right? So again, on one side, the publish process is very quick. You have a lot of content that's available to you. There's also a fab within that which allows you to get a lot of assets. So this is UEFN, and then remember that it doesn't have all the features that exist in Unreal, right? It has some of the features, but what's also new is, this language called Verse that allows you to author gameplay and interactivity in your Fortnite experience. So for everybody who uses Unreal, I just want to introduce you to two new asset types that are specific to UEFN. And you need to understand these before we dive a little deeper. So a prop is the first type I want to cover. It's largely decorative. It's something that's populating your gameplay environment, right? It's something that doesn't really, you can't really, it's not contributing to gameplay, right? So it's a little bit like a building or a mesh or something that's lying around. So you can think of it like a static mesh, but it has a bunch of other features that work in conjunction with some of Fortnite's systems. So it works in conjunction with like Fortnite's damage system. So if you shoot it, it will kind of respond to that. It can get destroyed. So you have props. Its behavior can't really be changed because it can't control anything, but it can be controlled. Let's put it that way. On the other hand, you have a device, right? And a device is, you can think of it as a modular piece of interactivity or gameplay. So you have a bunch of different devices that work in conjunction with each other. And each device is intended to perform a specific task. For anybody who's played Fortnite, you've already used and interacted with these devices before. You'll find things like item spawners or mutator zones. And what you can also do, right? And this is something we'll talk about that Verse will allow you to do. You can create custom devices as well. So Verse is going to allow for that. But the one thing that you need to understand about both these types of assets is you have to take them and place them in your level. So UEFN also has a content browser. You will find your props and devices in there, and then you basically populate your level. And for your device to be functional, it has to be dropped into the map. So let's talk about what Verse is. I'm going to hand over to Sid.
So Verse is a new programming language that is in current active development by Epic Games. Now, there's a couple of design goals that were used to create it. So the first one is that it should be simple enough to use for new programmers. Now, let's just take a step back and just talk about C++ for a minute. Now, how many people had a lot of trouble starting out with C++? Can you raise your hand? Yeah? So, okay, not that many, but still. So C++ is considered to be a fairly complex language for first-time programmers. And the idea with Verse is that Epic is trying to create a language that is much more simpler for newcomers to programming, all right? Now, that is not to say that Verse is always easy. There are, as you start looking at more features from the language, the complexity of the language also increases. However, a lot of the basic building blocks allow anyone with a little bit of experience or with just a little bit of practice to create simple games inside the editor relatively quickly. Next, so Verse is performant for writing multiplayer games. So Verse is built from the ground up with multiplayer in mind. Next, we have catching runtime problems at compile time. And this is a very important and also very interesting aspect of Verse. And this is what sets it apart from some of the other languages that, such as C++, for example. So let's just take a simple scenario for starters. Now let's say you're playing a game of Sekiro, all right? Has anyone played Sekiro over here? Yeah? All right. Now let's say, take the hardest boss in there. Let's say that you're at the last stage of beating the boss and the game crashes, all right? That is what we call as a runtime exception or a runtime problem. Now, why did that happen? That's because the game code ran into a certain scenario that it couldn't handle, so ultimately it just crashes. Now, to the player, that is sometimes a very annoying problem, like in the case of Sekiro. I've myself experienced a lot of those crashes while playing. On the other hand, for developers, it is an even more problematic scenario because not all runtime crashes are easily reproduced in a development environment. Sometimes it takes a significant amount of effort to just find those issues, even with player reports, all right? So Verse takes a very different approach to that problem. It essentially converts those runtime problems into compile time errors. So what that means is, as you're developing and as you're compiling, if you run into any problems, if you run into any compile time issues, those could potentially be fixed at compile time itself. So Essentially, you don't run into any runtime issues with verse. All of your runtime issues now get converted into compile time errors that are easily managed and that are under your control. And the last one is that it has built-in concurrency. So the idea with verse is that there's a lot of basic primitives provided within the language itself that make writing concurrent code much simpler than what you would expect it to be with a language like potentially C++. All right?
Yeah, so great point, Sid. And just one more thing to touch on, right? Verse is, right now we're talking about it today primarily in the context of UEFN and how it helps you create experiences for Fortnite, but it also intends to be a general purpose programming language. And what is currently available to us within UEFN and that ecosystem is something called Shipverse, but there's a much larger framework that's being worked on, which is called MaxVerse. And Verse is actually, it's been in the works for a while now. The CEO of Epic Games, Tim Sweeney, has been very, very closely involved in the design of the language. And he's working with some of the best in the industry, the likes of Simon Peyton-Jones. And you have engineers and developers like this that have put their minds together to come up with this language that intends to be, one of the languages that will help build what we want to call the metaverse at some point. And that's why it already at this point in time, the fact that it works in Fortnite means it scales over millions of users. But it's set up in a way, in the way it's handling concurrency, in the way it's handling transactions, it's going to scale to handle billions of these, right? So Verse is still new, and it comes, it works with a lot of different paradigms. So it is a functional programming language. It can be used with that paradigm, but that doesn't block you out from using it with an object-oriented paradigm or something like that. And we'll see a lot of support for things that you're already familiar with. So we'll be getting into how classes, variables are structured, all of that. And what we're going to do is we're going to just help you transition your existing knowledge of blueprints in C++ into Verse over the course of this talk. So that, now let's go back to why you want to use it with UEFN, right? So even before UEFN came about, people did have one option to create custom content for Fortnite, and that was through Fortnite's creative mode, right? So that's been around for a while, but that is essentially a mode that you just, in the game itself, you switch. You're a third-person character, you're running around, just like you're able to build in the game, you're able to create maps and functionality like that. While it's simple and easy to use, it doesn't give you the level of control an editor gives you, right? So that's why UEFN comes in and it gives you that control. And UEFN, when you open it at a first glance, it looks very much like the Unreal editor, even in terms of the layout. You'll be right at home if you open it up. But when you're in UEFN, right, it's a little like the Blueprint and C++ analogy. There's a certain amount you can do in Blueprint and it works really well. But when you want to go under the hood and you want to manage that code better, that's where Verse is going to kick in. The first thing that Verse allows you to do is create entirely new types of functionality that's simply not possible in Fortnite creative mode or within UEFN, and where you're just connecting devices and doing things like event binding. So Verse allows you to create a lot of those functionalities. Secondly, it's text-based, right? So it allows you to manage this complexity very well. You're not navigating some 3D map with 20 different devices with settings in the details panel over there. All of it is cleanly available in your IDE. You could use something like Visual Studio Code today with Verse, and you have all your Verse files neatly organized. The other thing that allows you to do well is it allows you to collaborate with your teammates really well. Because with something text-based, you can take advantage of merging, diffing, all of that, right? So this is something that makes Verse very easy to manage complexity. You've got a good code base, and then you have the ability to build up libraries and digest files that we'll talk about a little later. Secondly, if you go with Verse, it doesn't block out any of the old creation modes. So if you have somebody who is not a developer or an artist and they still want to just use creative mode, they can go ahead and do that. It's not going to break anything. The second is, if you are working with a technical artist or something like that, Verse allows you to expose certain parameters in the code. And just like you would with even C++, it allows designers to take control of features that have been created in Verse, and they can change settings and do things like that. So ultimately, it leaves you with fewer limitations around what you can develop.
All right, so will be the rest of the session or the rest of the content will be with respect to the following two demos. So it's essentially the same template, but created in two different editors. The first one is in UEFN, and you'll see that at the end over there, there is a rock, basically a rock prop that is turning invisible and visible as the player enters. Now, in a similar fashion, on the Unreal Engine side, we have a blue cube that is on the top left-hand side. And essentially, again, when the player enters a trigger box over there, the cube it toggles its visibility accordingly, right? In the case of the UEFN demo, we have a mutator zone device that is acting as the trigger zone for detecting when the player enters and exits. Now, after this, we'll be looking at the verse code over here. So this is just the overall verse code that was used for creating the sample that you saw on the previous slide. Now, one thing that you would want to note here is that the verse syntax is very different from C++, right? Now, we'll be breaking down this code into smaller parts, and we'll be explaining each of the parts over the next couple of slides.
So I just want to give a few pointers and put this out there, because if anybody's transitioning from blueprints to verse, you absolutely have to keep all of this in mind. The first thing is case matters. I want to make that very clear with that bullet point in the way it's written, because a lowercase or uppercase name is going to, even if it's one character over there, it's going to make all the difference. It's going to break if you don't do that, or it won't be able to find the right reference, right? This is not something that matters too much in other languages, but in some definitely. And with Blueprint, Blueprint is a little more forgiving over here with these types of things. Secondly, you have the fact that indentation is very important over here. And in Blueprint, indentation doesn't matter. You can move your node anywhere. Where it is in terms of that dev graph, it has no impact on how it's performing. Over here, indentation actually helps you define scope. So if you see, we have a device over there, and then we have 4 spaces, which are effectively the tab over there, and then you have the onBegin function. So the scope is being defined by the indentation. How much you space it, right, is going to help you define the scope. So the compiler reads through that indentation as well. Now, so keep these two in mind. Now, here's one really, really good thing, right? It's multiplayer out of the box. So if we work with blueprints and you're trying to build a multiplayer game, you know what you have to do when it comes to replication. There are a lot of different settings, things you have to keep track of. Verse tries to handle all of this, right? And it does this in a very interesting way. So when you use blueprints or when you're working with C++, it's largely just working with the client in mind, and then anything that needs to be replicated, you're kind of dealing with things that, Verse, on the other hand, runs on the server. It's server authoritative, whereas blueprints by default are client side, right? So Verse is running on the server. That means it's multiplayer out of the box. So you don't have to deal extensively with these things. Lastly, anything that, if you use the hash sign, anything following that is going to be in green, and that's basically a comment. The compiler is going to ignore it. It doesn't care. But still very useful to help you document your code. So we're used to commenting our nodes when we're working with blueprints. With Verse, make sure you comment your code. Again, C++ devs do this all the time anyway, but just make sure you're doing this. Okay, so let's move to familiar territory. Again, we all know what variables are as programmers, constants as well. And we'll just talk about it a little bit in the context of Verse today. So you will find a lot of variable types that you're familiar with, right? You'll find your ints, you'll find your floats, you'll find your strings, you'll find things like that. Verse also allows for composite types as well, right? So these are types that are built out of other variables and data types. So you have, things that you may use in Unreal. You can create structs, all of that. You'll also find some really interesting types that are specific to Fortnite. So you'll find, like variables for devices and things like that, or even the player itself, right? You'll find different types for that. There are some types, and one important type that's not there, and it's kind of morphed a little bit. So there's no Boolean, it's just logic. The type is logic, it's true or false. And the interesting thing about all these types in Verse is they're derived from one super type called any. So everything is derived. So that means that you can also have, types that are derived from, and that gives you custom types effectively. So you can go ahead and create your own custom types. Lastly, verse is strongly typed, right? And this goes back to what Sid says. The language tries to leave out any ambiguity. So over here, any identifier, and anything you're initializing is going to need to have a type, right? Without the type, so it doesn't want to leave that open for interpretation. Again, to keep things stable, so you may need to be it wants you to be specific from the very start, moment you declare something. So we're all familiar with how variables are created in Blueprint. It's very simple. You'll find that hit the plus button, select your type, give it a name, and then you select whether you want it to be public or private by toggling the I icon over there.
Now on the C++ front, again, things should be pretty familiar for Unreal C++ developers. So we start with the uProperty macro. We pass in a bunch of specifiers. Depending on how you want to make the variable visible to Blueprint, so things like edit anywhere, Blueprint read only, Blueprint read write, etc. There's several different specifiers available, depending on the kind of operation that you want to set up for the variable. Next, you then start by declaring the type, whether it's a pointer. If it's a pointer, then you have a star. If it's a regular variable, then you just have the data type and then the variable name. Now, this is all done inside the header file, the .h file of C++. And now, in verse, things are very different.
Yeah, so let's look at what a variable looks like in verse, and let's just try and understand the syntax, because if we start here, you'll be able to understand how you can create other types of variables and constants as well. So if you take a glance at both, they're quite similar. The one thing that differentiates a variable from the constant is the fact that you have to use a reserved word, which is var. So var signifies that this is going to be a variable. And it's important to do this, again, going back to the stability aspect of verse, right? Things are immutable by default. So verse intends to be a language that's deterministic. And what that means is you want the outcome to be predictable. So it makes default data immutable. That means that value is not going to change by default. If you just sort of create something, it's going to assume it's a constant. So you need to use that reserved word var to specify that this thing is going to be a variable. Following that, you just have the name, like you would in any other language. Just make sure the name makes sense. This is basically something that's going to be related to your game. Player speed, health, whatever it is, right? Name. So you put that, then you put a colon, and then you put what type it is. So you have access to all the standard types I mentioned, as well as a number of custom types, and I'll tell you where you can find some of these types as well. So the first half is basically your declaration, and following that is your initialization. So the initialization section, everything after the equal sign, and then whatever value you want to specify for that. So it's basically split into these two, and you can see that here, right? So just a variable we had used to kind of track the state of the mesh, whether it's going to be visible or not. It's that new type called logic, which is going to function like a Boolean. So it's just assigned false, at start. And we have a comment up there as well. There's one more thing over here. You might have noticed a difference over there. There's a constant, and right above the constant, you have the @editable sign. I'm going to mention exactly what that is on the next slide, so you're going to see that. But you can use an @editable for a variable as well. And what it's really going to do is, it's going to make this instance editable. So if you've worked with Unreal Engine before, so this is awesome because, as a verse programmer, if you use the @editable over any constant or variable, any designer or artist who you're working with is going to have access to this, and they can change the value or select a specific reference in their map, right? So they don't need to open the verse code at all. They're not touching it. They work in the editor itself. They don't have to open Visual Studio Code, and then they can start changing this. So it's the @editable. It's an attribute you put before your variable or constant that gives you access. So this is super handy, especially for devs and who are interested in working with artists. Okay, so modules and classes.
So let's explore what a class looks like in Unreal Engine first. So inside Unreal Engine, there's always going to be two files. Unreal Engine C++, that is always going to be two files. First one is your header file or your .h file, and the other one is your implementation file or your .cpp file. Now, the class definition over here, I'm sorry, the class declaration over here, starts off with include statements. So include statements link other files with internal code, like maybe math code, networking code, etc. That's already pre-written, and that ships with the engine and allows us to utilize those capabilities within our own code. So we need to start by providing a hash include, then get the path of that file and link it inside the class. Next, we have the uClass macro. This acts as a macro that allows us to modify different aspects of the class. Like if you want to make the class blueprint visible, you can add a specifier inside that. If you want to make it abstract, you can add a specifier inside that, and many other things. Next, we have the class. Declaration at the bottom. So that is the class name followed by another macro followed by the class name, and finally the parent class we're using. So that's basically how inheritance is implemented inside C++. And then finally we have the generated body macro, which is used to create additional code that is expanded when we compile the code later on. Now all of this is a lot of work. Right, it's a lot of work, and the scope of making errors over here can sometimes increase because of the usage of these macros. So sometimes you might see that you get some errors showing up on generated body. So those errors are because the generated code itself has certain errors internally. Now, as we'll see in verse, things are slightly different.
So this is what it looks like in verse, and what we see up there, right, it's using the fortnite.com/devices. So this is basically going to point to something called digest files. And when I hit F12 on that, right, I can take my cursor, and basically once you go there, you get to see all the different devices that are there. You get access to all the functions those devices have. And there are many more digest files that are there. So there's the unrealengine.com digest files as well. So if you want to work with vectors or something like that, let's say you want to include characters, right, you can. And this is all from Fortnite.com. So just from a very personal standpoint, what I've found useful is going through these digest files. It informs you of what's possible within and what you're trying to create, right? So it has the full list. It's an API as well, so you can see that in there. And then you can use those functions. You know exactly what parameters those functions are expecting. And if you use a function that is, you know, something that you might think of and you haven't included the digest file for it, it even prompts you, right? So in your ID, you will get a prompt and it will tell you to try and include, you know, the necessary digest file that's there. And over here, we can also see, following that, right, over here we have, so we're creating a custom device by doing this effectively. And so the colon equal sign is basically initializing it. And we're inheriting from, you know, the default Fortnite device. So that's called a creative device. It's a class. It has many functions available. So we're just creating our own custom device called Hello World device. That's on the left over here. And then we're creating, and then the body of the class will follow after that. So it's pretty straightforward over here. You just need to add the right, you know, digest files you want to work with. And inheritance is also functional over here. So just talking about, you know, now the functions, right? This is what that function would look like in blueprints. This is basically taking care of visibility toggling, right? So again, for everybody who knows blueprints, this is pretty simple. I'll walk you through it very quickly. So we have one Boolean that's just holding the state of the mesh. And then when your player enters that trigger box, it's going to try and check that Boolean. And based on that, it's going to change the visibility, right? And once the visibility is changed, it will just change the state of the Boolean. So it acts a little like a flip-flop, right? Each time you enter, it's going to change the visibility and then change the state of the variable. But you can see, obviously, a lot of nodes being used here. You can simplify it a little bit as well. But I just wanted to make it very clear over here because there are certain things you can't do in verse, and you know, we'll touch on that later as well.
So the next one is C++, the C++ equivalent. Now, again, it's the same toggle-based code that we have here, but you'll see that there's a lot more that is present in here. All right, so let's start from the header file first. So we start by using the uProperty macro as always because we want to be able to expose these variables for designers to utilize inside the engine. So we have a trigger box, we have a mesh, and after that we have U function at the bottom, so the on overlap begin, that is the function that we are using for essentially acting as the event handler when the player enters into the volume, all right? Now, all of this is done on the C++ header file side, that's the .h file. Now let's come over to the implementation file, or the part where all the code is actually defined. Now, on the top, we have the begin play event. So inside that, we are checking if the trigger box is not a null pointer. If it isn't, then we subscribe to the on actor begin overlap event, and we assign our handler to it. Now, one quick note over here that I'd like to point out is if you somehow end up missing that if trigger box check on the top, and say you haven't assigned it inside the editor, the engine will crash if you try to access it, all right? So this does not happen in verse because that if statement in verse is mandatory. If there's a chance of crashing inside verse, then you'll actually get a compile time error at that point. So that's a very important difference between C++ and verse. And lastly, at the bottom, we have the on overlap begin function, which is basically the handler, which toggles visibility depending on whether the mesh was previously visible or invisible.
So let's try and understand the syntax for functions in verse. This is pretty straightforward, and there are some interesting things over here like attributes that we'll see a little later as well. But you just start with the identifier. That's the name of the function. Following that, you want to have your input parameters, right? So whatever the function is going to take as its input, you need to specify the type as well. So that's in your round brackets. And basically your round bracket, it's indicative of a function. Then you have attributes. We'll talk about attributes more in depth and show you one example. But this is where you specify the nature of the function a little bit as well, whether it's going to be something that's asynchronous, or if it's going to deal with concurrency or transactions in a certain way. That's always going to be specified in the attribute section. Following that, you have the return type. So verse does support void. So if you have a return type that is not particularly meaningful, you can use a void over there. Otherwise, you could go with like an int or a float or anything like that. And then you have your function body. So the function signature can get pretty large in verse, but we do that to be very specific about the type of function this is. So this is what now, so we saw the blueprint and C++ equivalence. This is really what's happening in verse over here. So we start with the onBegin function. This is something that is already a part of any device, so we're overriding it. So it starts with the override, and then it's a void function. And then following that, we have something that's similar to event binding. So the subscribe over there is like an event binding. Basically, if you saw the example that Sid showed earlier, it's the player running into that mutator zone. So we have a reference to that mutator zone, and then we've created another custom event. So agent enters event is there, and then our custom function is the on agent enter. So that's what we're defining next. So once the agent enters that, we're just doing a visibility toggle over here. So that's that same prop hidden variable we had at the start. And then prop.show is a function that exists for that specific prop, right? So a prop is a type, it's a type of asset in Fortnite, and it has functions like show and hide or move. So this is all part, you'll find this in the digest file. So this is basically what's going on, in that module of gameplay. So it's quite elegant. Unlike C++, you can have this all, it's in a single file, but you are able to create, custom modules as well with verse. So if you want to house something in a module, but you don't have to have the concept of having something like a header file and then another file where you're, right. So the variable is also defined here, and then you can define the function here as well, and then actually the function body is functioning here. So just diving deeper into attributes, we want to talk a little bit about asynchronous functions, and we saw an asynchronous function last time as well. We'll dive deeper into it now.
So for exploring the asynchronous function, we'll be looking at another sample here. This is a much more simpler sample than the previous one. There's basically just a big rock again at the end, and it just disappears after 10 seconds. All right, that's all that's happening here. But while the example is fairly simplistic, we'll be showing you how we can actually set this up inside verse, and we'll be also giving you a bit of a comparative overview of how this would look like in blueprints and C++ as well.
Blueprint is extremely simple, as you can imagine. We have a custom event with a delay. So your delay is acting asynchronous anyway. And then we are just setting the new visibility state of that mesh, the static component for it. And yeah, that's all that's happening over there. So super simple blueprint.
Now, on the other hand, C++, while conceptually simple, still is a little bit involved because there's a lot of code that you need to type. All right, so let's start from the header file again. So we have a timer handle. This is used for tracking the timer itself. Then we have the onHide mesh function, which is the event handler when the timer finishes and it executes. And lastly, we have the wait and hide mesh, which sort of starts everything. So let's now head over to the implementation file. Now, on the implementation file, in the begin play function, we start with wait and hide mesh. Inside wait and hide mesh, I get a reference to the world timer manager. From there, I set a timer. I pass in things like a timer handle, the current object that it references, the handler that will handle this particular event, the rate, or rather how much I need to wait before the timer executes, and finally whether I want to loop the timer or not. So there's a whole bunch of parameters that need to be passed in for just a simple thing like setting up a timer, all right? And after that, we have the onHide mesh. So again, inside here, we have to check if the mesh is not a null pointer. Again, if it is, and you access the set visibility function on it, it will crash. And after that, then, after the function executes, after the handler executes, clearing the timer is also necessary. So there's a lot of steps involved in setting up a timer in C++. And as you might expect, things will be rather different inside verse.
Yeah, with verse, it's pretty straightforward. So we have to use the suspend attribute over there. So you can see that right after the function is defined over here, we have the wait and hide prop, and then suspends. So when you put suspends, it understands, the compiler understands that this is going to be an asynchronous function, and it's going to take its time to finish. Again, this is done for the sake of stability, right? So sleep over there, and sleep is a function again, and sleep is very much like delay, right? So it's just going to accept a float. We're putting 10 in there, so it knows it has to wait 10 seconds. You can put another variable in there as well. So this is how an async function would work in verse. So event begin play, right? We need to make sure it is an asynchronous function over here, and the way that we're using it on begin, if you want it to work like event begin play. And verse doesn't offer something like a tick function, so you'd have to create something like that using an async and then a loop, right? So it doesn't just exist in that way, and this is again for the sake of stability, right? To avoid any kind of runtime errors that would come up or any issues between threads as well. So it just understands that this one is going to be asynchronous. Okay, so we've seen a simple code sample today for something as simple as toggling visibility. If you want to see more code samples and contribute as well, I would highly recommend checking out the snippets that are on dev.epicgames.com. This is part of the community site. And under Fortnite, you'll find snippets. So you'll find a lot of functionality for verse. So if you're curious about how you can do something in verse, there are a lot of things over here as to, how even UI, right? So a lot of the UI work you can do, custom UI work, would run through verse if you're trying to create a highly customized island. So you'll find, a lot of contributions from developers at Epic here, but also a lot of community contributions. And you can add your own. Sid and I have added some of ours up here as well. So check this out. You can copy and paste that code, and really this allows all of us as an ecosystem to understand this language better, understand how we can use and reuse features without everybody trying to figure things out from scratch. Okay, so this is what it's like to just compile your verse code. It's very, very simple. You need to leave Visual Studio Code, jump back into the editor. There's a verse button up top. You can hit that. This is assuming you have no errors in your code. It's all just going to compile. In the case that you do have errors, it's kind of nice because you don't have to wait and run the game and find out there's something that is seriously wrong. It's going to try and point that out in the ID itself. You'll just find these red squiggly lines at the bottom and some hint about what the error is. If for some reason you miss that, and if you try and build your verse code, it's going to kind of flag that in the log anyway. So it won't allow you to, so unlike, over here, you may run into some kind of logic error where your game is not functioning with the logic you expected, but nothing that's really going to break it or make it crash significantly. So this is how that takes place, and errors are very easy to catch in verse. It is it is statically verified. So that's been the design intention for the languages. You don't want surprises later. And then running verse code. So this is really interesting, right? This is a huge difference from what you do in Unreal, where you just hit the play button, see things, see the game work in your viewport. You actually can't do that in UEFN and verse. And there's a reason for this. It has a lot to do with verse running on the server. Like I said, verse itself is going to run on the server. So what it does actually, when you hit launch session, it's going to launch Fortnite, right? And it's going to launch an executable for Fortnite, and then it's going to basically deploy it over there, and that's how you test it out. So you kind of exit UEFN, and then you're in the game itself. You're in Fortnite, and yeah, that's it. And that also leads to a very, very streamlined publishing process after this, because you've caught all your bugs early. You've pushed it into Fortnite. You're not just testing it locally on your. So if you test it on any other machine, you can expect the same behavior, right? It's not really running on the client in that same way. It's running on the server effectively. So that's the beauty of running burst code. And this could take a little bit of time, like Sid says, depending on how the server is feeling that day. It could take a little bit of time, but it's typically a few minutes, and it's generally fast, because the trade-off is you can publish very quickly. Right, yeah, snippets again. And yeah, that's our overview today on how you can, just some tips on how to transition from blueprints in C++ to verse. But I think it's also very clear that verse is just a different animal, right? It's a different, again, it has a lot of, features that come from the world of functional programming. So while we looked at analogies, you need to understand that verse has its nuances. It's still the early days of this language, and it's going to keep getting better and more evolved. But it's going to work well. Also, Tim Sweeney kind of hinted this earlier in one of his tweets, and actually a forum post as well, saying that there may be, you could potentially expect some support for verse going back into the main engine as well. So this would happen in a little while, but again, so there's value in learning verse just outside of UEFN as well. Again, it's intended to be a general purpose programming language. And yeah, that's, we just want to leave it open for some questions right now. We have a little bit of time left, and if we run out, Sid and I will be around and we can chat more.
Yeah, so on the very last point, given how much focus there is on verse, is there a major expectation that if and when Unreal Engine 6 or future developments come, the main engine will also be using verse as its primary programming language?
So obviously we're not able to comment on the next version of Unreal or anything of that sort, but it's been very clear when verse was launched that this is intended to be general purpose programming. And yeah, it could totally, like you could at some point see the language is set up in a way that will allow for it. Doesn't mean that it needs to happen or will happen, but it's totally built in a way that's possible.
So no comments basically.
No comments. Yeah, I can't comment on that. I don't know, honestly, I don't know, and I can't comment. But see, if you look at some of the forum posts as well, if you're tracking what's happening on verse, it's very much built with that possibility.
What does the workflow look like for multiple developers on a team?
Okay, it's a super question, right? Because one really, really good thing about UEFN and that ecosystem is that collaboration is inbuilt. That means Unreal has its own version control in here. You don't need to use something external like Perforce or Git. It's all built in, right? So when it comes to verse, again, your verse files, unlike blueprints, which are very hard to diff and merge and all of that, super easy to do that here. It's text-based, right? So that's the first thing. So as you're collaborating with other developers, it's kind of working through Unreal's native version control system that's built into UEFN right now. So you can set up teams effectively, and then anybody who's a part of your team is able to contribute to that project, access and edit those verse files. And you can also do things like lock certain files and all of that. So that's the collaboration workflow.
But when the code gets deployed, I believe it goes to the Fortnite server, or so does the sync always happen if I'm having multiple developers? How do I version my
So that has to do with the publish process, right? Over here, you're largely testing, and what it's doing is it's running an instance of Fortnite, but for it to go into the Discover tab or something like that, right? That CI/CD pipeline, there is the standard publish process, and you do need to be, an approved publisher first. It's very simple. There are just some ground rules. You need to use UEFN for a certain period of time and just supply basic information. You need to have an entity and all of that as well.
So each developer on the team runs Fortnite, but the versions don't sync essentially. Only when we go to publish as a team.
And yeah, that thing itself could be a whole talk in itself as to how you use Unreal version control. But it's got a lot of aspects that are similar to things like Perforce, where you have changes that are being pushed and you basically synchronize.
Thank you.
That's a great question, but I've never found an easier sort of integration than this because it's not third party, it's built into the editor itself.
Hi. So one of the important aspects that a programmer looks for is debugging. How does debugging work with verse?
So right now, there's not much of support for debugging. The best you can do is add print statements and look at those show up in the output log inside Fortnite. There are talks of bringing in better features as more updates are brought in, however.
So like you can put breakpoints in Blueprint, those kind of things are still yet to come.
Yes, that's yet to come.
But just with what Sid said, right? So obviously one of the things that Verse is trying to do is trying to catch those errors in the editor itself, in your IDE itself. So you have less back and forth, and then the other thing is you do have to actually see how that gameplay plays out, you do need to run it in Fortnite. So that round trip takes longer than it would in something like Blueprint, especially where it just takes you back to that node with F9. You would have to kind of run it and then see how the performance is, right? But when you're debugging, you're debugging more from a gameplay standpoint rather than a stability standpoint to make sure there's some uncaught exception or error or something like that.
Fair enough, thanks.
But yeah, I think it'd be nice to see more debugging infrastructure there. Yeah. I think we feel that way as well.
That's one of the bread and butters of a programmer.
Yeah.
So.
And just one more thing, right? So typically, if you just want to build verse code again, it's very fast. That takes a few seconds. So if you're just going back and forth between UEFN and Visual Studio Code, that is pretty quick. You don't need to do the full round trip for that.
Yeah, hi.
Hi.
I want to understand what the pace of progress has been for verse, like the updates that have kept coming in. It's a brilliant initiative, scripting language, it's great. I want to understand, there are still a lot of things I understand they are in works and can't wait to see them, but just want to understand, just want to get an idea about when can we see more updates, more additions to verse, more tools to be used.
That's a great question, right? And look, I can speak a little bit from our experience, right, since March to now, right? Because when we started specifically around the UI, there were a lot of limitations as to what you could do. And even with, AI, and I'm talking about like guards, right, NPCs type AI, not generative AI or anything like that. That, was like people, since it wasn't, the API for that stuff wasn't available, people would do very hacky things to put it together. But right now, just, about a month ago, Sid has been exploring the AI API for specific. So we're seeing every quarter you can see pretty significant jumps. There's also the roadmap. So the roadmap has been listed. I think what's coming up next is just a much deeper dive into concurrency. So that's going to be the new thing that's coming up. And you should just check out the roadmap. It's kind of structured quarterly, so you can see what's coming up.
Great, thanks.
Yeah, and just one more thing, I mentioned Maxverse earlier. So just keep your eye on what's going on there. You can see what's happening at the overall language level. But before they bring it into the UEFN ecosystem, it has to be very stable because this is something that millions of people are going to play potentially. So you don't want a broken experience there. So there needs to be a lot of QA for that. But and there's some really interesting developer communities, like at the Haskell conference. Right, there was a huge talk, again, a bunch of people who are deep into functional programming were looking at this. So I think it's developing very, very rapidly as well. Last question, I think we're almost at time. Yeah.
Hello. Yeah. So let's say, for example, from an artist perspective, you have a blueprint file in Unreal. Okay, you want to bring it into UEFN. So is there a way to do it?
No, not really. Not at the moment. So you'd have to understand that algorithm translated to what it would be in verse. There's nothing of that sort at the moment. It would be nice for verse to support a visual interface, but I can tell you that with the way the language is built, you wouldn't be surprised if there would be something blueprint like Node like a visual interface for it. But at this point, there's nothing of that sort. And while you can port a lot of your Unreal maps into UEFN, blueprint script doesn't transfer over.
Yeah,
So there's nothing for that right now.
I transferred some of the blueprint files, but
It won't
they're showing
work.
like unsupported.
It won't work, and it has to do with the architecture because, like I said, blueprint by default is just considering the client, right? Like the way it deals with replication, all of that, it doesn't make sense for verse. So you would have to basically rewrite that algorithm and translate it to verse.
Yeah, thanks.
Okay, thank you everybody.
Thank you,
It's been a
everyone.
pleasure to be here. Thank you to Epic and IGDC for having us here today. Thank you.